Okay, they're being noisy today. It's Friday. Lacey. They're just being crazy. Okay, so we started these notes, Lacey, and then I forgot that we were supposed to be videotaping. So sorry. So we're talking about slope. Rise over run. We did rise over run down here, and I started doing it wrong. But the rise over run is 1/2. So y2 minus y1 over x2 minus x1. We are now on example 2. We are now on example 2. Hush. L2, line 2. 0, 2, and 2, 4. So we are doing y2 minus y1 over x2 minus x1. 2 over 2, which is 1. There's L2. Yes? Okay, I'm going to skip. No, we're going to do L3. We're going to do line 3. And then we'll skip the next 2, okay? Line 3. Those are my 2 coordinate points. So I have 2 minus 2 over 3 minus a negative 6 or 3 plus 6. So that is 0 over 9, which is 0. 0 divided by 9 is 0. So that guy has a slope of 0. What does he look like if he has a slope of 0? What? Which way? Well, all of them are straight lines. Which way? Horizontal. He has a horizontal line. Okay. Now, what is the slope of a line that goes up and down? If it's a vertical line, what's its slope?
Down 1 over 0.
It would be like some number over 0 on the bottom, which is undefined. So an up and down line is undefined slope. Yeah?
Yep.
Yes, yes?
Yep.
Okay. This next box has like multiple representations for linear functions. Yeah? So this guy is called standard form. AX plus BY equals C. So I'm going to give you an example of that. Let's say I have 2x minus 3y equals 6. Let's do that. 2x minus 3y equals 6. That is called standard form. Okay? Now, I don't like dealing with stuff in standard form because I don't know how to graph stuff in standard form. I like to do slope-intercept form, which is the next one. Y equals mx plus b. So we need to get y by itself. So let's get y by itself. What do we do first?
I'm
I'm going to subtract the 2x. So negative 3y equals negative 2x plus 6. And then divide by negative 3 on everything, right?
Wait. Can we swear?
I'm going slightly fast here. Slightly fast. So yes. I'm pausing. Pause.
How'd you do the
Win. Turn around.
T.
You have the 3y, negative 3y, you have to rid of that negative 3.
And then you get y.
So, starting in standard form, anything in standard form, we can make it into slope-intercept form by solving for y, yes?
Yeah.
Now, they also have something called point-slope form, and I'm not going to deal with point-slope form because I hate it. I don't like point-slope form very much, okay? It has a time and a place. Listen, it has a time and a place. Point-slope form is important sometimes. Slope-intercept form, I think, is easier, always, okay? So, there you go. A horizontal line, it says, has a slope of 0. Horizontal line, vertical line has a slope that's undefined. That's those next 2 little pieces there. Okay, good?
Yep.
Standard form, slope-intercept form. Good. All right, next page. Now, why are we dealing with lines? Because that's what an arithmetic sequence is, right? That's what we learned in 1-3, arithmetic sequence and lines. The first 3 terms of an arithmetic sequence are negative 2, 3, and 8. Okay? Negative 2, 3, and 8. Use the explicit form of the sequence to represent the nth term, okay? So, y equals mx plus b. What are we adding each time?
X.
5. We're adding 5. So where does the 5 go in our sequence, right? 5 goes for m. So m is 5. Now b. This is the first term, but we just said on the quiz, the first term is not u1. It is not negative 2. That's going to be u0. Okay? So I need u0 here, which is not negative 2. If we are adding 5 each time, then to get back to u0, we need to subtract 5. So that's going to be negative 7. So y equals 5x minus 7 gets us back to normal. Yes? Okay? If I graph him, that means I start at negative 7. 1, 2, 3, 4, 5, 6, 7. Is it all the way down to the bottom?
Yeah.
I don't know. I can't count. 1, then 5 is my slope. So that means I go up 5. 1, 2, 3, 4, 5. And which way do I go over? To the right one, okay? If you instead accidentally go to the left one, your slope is going to go down. Your line is going to go down. But our slope needs to be positive, so that's the way that goes, okay? Graph both the sequence and the corresponding line on the same set of axes. So this guy is, if he is -2, he is 1, 2. He is 2, 3, and he is 3, 8. So 1, -2, 2, 3, and 3, 8. Do you see where those are? That would be those points. Those points should live on that line, right? What's up? Yeah, up 5 over 1. But I'm saying, like, these points, if you graph those points, we always associate this is the first term, second term, third term. So this is the point 1, -2, 2, 3, 5, or 3, 8. You plot those points, those live on that line, all right? All right, so connection between arithmetic sequence and lines. We've already figured this out. Arithmetic sequence is a line. We've learned that like day 1, right? Okay, so arithmetic sequence are lines. Y equals mx plus b. I'm going to write it again because it's important. M is the number that you are adding each time. B is the first term, which is not u sub 1. It is u sub 0 every time, okay? Because I need to be able to plug 0 in for x for the b to pop out. Okay? So it is the 0 term.
And be the number you subtract.
Yes, add or subtract. Yes. Add or subtract.
But Mrs. Porter, if it's going decreasing, how will I know?
What do you mean?
Carry on.
Just be quiet. Okay, so example 4. Graphing a line. Sketch the graph of this guy and confirm your sketch with the graphing calculator. Okay, well, I'll teach you how to do that maybe. This guy is in standard form. We want to put him in slope-intercept form so that we can graph him really easily, all right? So let's add the 5x. 2y equals.
Wait. I can't see what that says. Her writing is not on there.
We're writing that in standard form. Oh my gosh. Add the 5x to the other side. Then divide by 2.
Okay, now I'm
Hey,
Wait, let
if
me
you
write it
stop
out.
talking, if you turn around like I told you 4 times ago, then this will be easier.
Just kidding.
What?
We're making this guy from standard form to slope-intercept form. 5 over 2x plus 1. Yes?
Yeah.
Yes. Graph him. We start at 1. Positive 1. And we go up 5 over 2. Up 5 over 2. Or down 5 to the left 2. Oh boy. Something like that. Okay, that's the graph of our line. I said you could go up 5 to the left 2, or you could go down 5 to the right 2. Does that make sense?
What?
No.
Okay.
Get down 5 to the left and up
That's
5
what I
to the
meant.
right.
Scratch that, reverse it. Up 5 to the right 2, down 5 to the left 2. You're mirroring me. I'm mirroring you.
Mrs. Porter, you're not really good at.
I'm sorry, my left and right. I can't see that. I'm trying to get that. Alright, example 5. Move on. Here we go. Linear depreciation.
Do it later.
Here in just a minute, I will. An office, listen. An office buys a new computer system for $7,000. This is my start. Okay, 5 years later, its value is $800. End. Assume that a system depreciates linearly. Okay, so here's what's happening. I'm going to call 7,000. I'm going to call that not U1, but U0. Okay, I'm going to call 7,000 my U0.
Okay.
And the reason why it's not U1 because I'm using 0 to represent time, okay? At a time of 0, when I purchase it, at a time of 0, it is $7,000, okay? Not after a month of having it or a year of having it. 0. When I bought it to start with, I'm designating that as U sub 0, okay?
So if it said that it had been for a month.
Right, then you would put U1. Yes. So in story problems, I usually denote the first one as U sub 0, okay? All right. $800 is what's left over. So it reduces down to $8,000 or $800. I don't know why I keep saying that. How much did it depreciate over that amount of time? 6,200. If I subtract those 6,200 is how much it went down, right? Okay. In 5 years?
Yes.
5 years later, its value is 800. So 6,200 in 5 years. So how much is it depreciating each year? If I divide that by 5, it is 1250? 1240. 1240 is depreciating each year. Does that make sense to you? Before we move on. No.
When did you get the 5 because of like how?
5 years later.
Gotcha.
It tells you 5 years later.
That's the answer.
Hey, now just wait. Write an equation that represents the value of the function. Listen. Shh, listen. Write an equation that represents the value of the function. So we need, I'm running out of room
B
here.
is 7,000.
Y equals, B is 7,000 because that's what we're starting with. This is my number 1. And then what is the M? How much is it going, like how much is it decreasing every year?
1240x.
1240.
So
Okay?
negative.
And it needs to be negative because we're depreciating. So negative 1240x. That's right here. Negative 1240x plus 7,000. Ooh, yikes. Negative 1240x plus 7,000. That's our function, right? You can't see it very well, sorry, but write that in there. That's part A. Hey, now, they're going to say, okay, I want to know the value of it after so many years, probably, right?
So
In
there's-
part B, find the value 2 years after it was purchased. So that means we're going to plug 2 in. That's it, right? For x, y equals negative 1240 times 2 plus 7,000. And that number is 4,420. 520. 4,520.
Okay.
4520. That's the value of my whatever we're purchasing.
We're not graphing.
I'm not going to graph the equation. You guys know how to graph linear functions. So we're going to skip part C. Sorry. Find how many years before the system is worthless. Okay? If it is completely worthless, then that means its value is 0. But where do I plug 0 in? To the y. 0 is going to be y, and I'm trying to figure out what my system is worth.
Now, wouldn't it just be 6? Because if 5 is 800.
5 years
Okay, so let's go over that again. Everybody be quiet. Find how many years before the system is worthless. Y is telling us, the y variable is telling us how much it's worth at any point in time, right? So normally I was plugging in for x and getting a number for y, and that tells me how much it's worth. But if it's worthless, then that means I have 0. And I'm plugging 0 in for y.
Subtract 700.
Okay, just wait. So Liddell, 0 goes in for y. Now I'm trying to solve for time, which is x. So I'm going to solve for the amount of time. All right. So, what do you want to move? Move the 7,000. Okay, sure.
No, it's not though. I guess it's
Then divide by negative 1240.
It's even. So it's that.
So x equals
5.65.
5.65.
But because it asks for years, you need to round it off to 6.
Just leave it as 5.65 years. Okay? Unless they say the whole number or whatever. That is the x value. After how many years? 5.65 years. Just go ahead and say 5.65 years. Right? That's fine. That's fine. Okay? What time do we get out? 56? 54. Oh, we got lots of time, kids. All right.
You need to show us how to do the graph.
I'll show you here in just a
I
minute.
still haven't even got my map stuff.
Okay. All right, so example 6 talks about point slope form. We're going to skip point slope form, but every question on your homework that says point slope form, I want you to put it in slope intercept form. So what we're going to do is sketch the graph and find the equation of a line that has a slope of 2 with the point 1, negative 6. We're going to do this not in point slope form. We're going to do it in slope intercept form.
It says to do it in slope.
Okay, whatever. But at the top it says point slope form of a line.
But they trick you.
Whatever. So we're going to do y equals mx plus b. Okay. So these are the 2 pieces of information it gives me. My slope is 2 and my point is 1, negative 6. So
2 is
2 is M. 2 is the slope, right?
Buddy.
Because B is right.
Okay, now we need to find B. This way. I know you have the answer. This way. So we need to find B. So what do we do now?
Let's do that one point.
This 1, -6 needs to go in here. Yeah? Negative 6 is Y, Holly said. Okay, don't get confused. Just because the Y comes first doesn't mean you put the first thing in there.
1 for the X.
2 times 1 plus B.
Now you solve for B.
Shh. All right, quit talking. Shh, shh, shh. Quit talking. I know some of you know what you're doing, but just be quiet. -2, -2. B is -8. You're subtracting, you're not dividing. -2, -2. B is -8. So my equation is Y equals, what was the slope again? 2x minus 8. There you go. Those show up like crazy all the time on ACT. Those should be super easy free points for you on the ACT. You do those a lot.
So now we have to
Okay.
graph it.
Okay, now we have to graph it. So go down to 8, and then you go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, etc. Okay? My graph is approximate. Graph better than me, because I can't see the lines very well. That's fine. Just guess.
Wait, up 2 over 8 or
Up
up
2
8?
over 1.
Oh,
You go down to -8, up 2 over 1. 2 over 1. Pausing. Okay. All right, we have already said, listen, we've already said that vertical lines have an undefined slope. Okay, it's undefined because vertical lines go up a certain number, but they run nothing, right? They rise however much, but they run nothing. That's why they're undefined. 0 on the bottom is undefined. So they're rising over running. Their rise is a certain amount, but their run is nothing. That's why the vertical lines are undefined, okay? So they want us to graph very fuzzy. Y equals
3.
3. This is a horizontal. Oh, shoot. Hold on. Let's talk about horizontal lines quick. Because they give us a horizontal line first. Horizontal lines have 0 slope because their rise over their run, they're rising nothing, but they are running a certain number, right? For horizontal lines, they are not rising at all. They are just running along, all right? They are not rising, they are just running. So horizontal lines, that's where the 0 comes from. 0 over a number is just 0. A number over 0 is undefined, right? So that's how that works. So they give us a horizontal line to start with. They say Y equals 3. Here's what you do. Go up to 3 on the y-axis. Put a dot. And then no matter what, it's going to be 3. So we're going to run that straight across. Y equals 3. Now, people get confused on that. Here's the confusion. Here's where the confusion sets in. If you have an equation that's Y equals 3, a lot of people think that should be a vertical line because the y-axis goes up and down, yes? Y equals 3 is a horizontal line. Yes, so think about it that way. You have to go to 3 on the y-axis and it's always 3. So don't get that confused. Just because the y-axis goes up and down doesn't mean Y equals 3 goes up and down, all right? Over here, find the equation of the vertical line shown. So this guy is going through the x-axis. So this has to be x equals 2. That's it. Yes? Okay, last one. All right, parallel, perpendicular. We are going to get through it. Parallel, perpendicular. Okay, so they do these like crazy on the math testing and on the ACT. Here is our equation of a line. It's going through the point 2, -1. We need to find a parallel line and a perpendicular line, okay? Parallel lines look like this. What's true about parallel lines? They never touch and they have the same slope. That's the important part. Same slope. Okay? Perpendicular lines look like this, right? Right angle. Okay. Perpendicular lines look like that. They have the same. Their slopes are negative reciprocals of one another. All right. So our equation up above is this one. 3x minus 2y plus 6 equals 0. We need to write that in slope-intercept form. Now, hold on. Here's what I would do. Let's add the 2y over. Then y is by itself, right? Let's do that. So plus 2y, right? 3x plus 6 equals 2y. Okay, and then divide by 2, divide by 2, divide by 2. So 3 over 2x plus 3 equals y. Or I'm going to put y on this side now. This is my equation to start with. Okay, I'll show you what I just did. So 3 over 2x. Oh man, they're fuzzy.
Yeah.
3 over 2x is my slope. Plus 3, rather than having the y on the right side, though, I moved it back so that it looks like normal, yeah? Okay? All right, so what is the slope of that guy? 3 over 2. So my slope for my parallel line needs to be 3 over 2. What does the slope of my perpendicular line need to be? Negative 2 over 3. So this guy, y equals 3 over 2x plus b. I never, ever, 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 ever use this. You cross him out, you don't use him. The only thing that we need the original function for is for the slope. Okay? So, and then we plug the points. 2, negative 1 in. So the 1 goes for y, the 2 goes for x, and then we solve for b, just like we did normally, yeah? Okay, we're going to run out of time, so I'm going fast. This one, we put in negative 2/3 x plus b. We never use this 3 over here. And again, we're going to plug 2, negative 1 in for there. Y is negative 1, x is 2, and solve for b. Then write the function. Good? Can I stop there? Because you guys know what to do? Hey, there you go. Do the homework.
Oh, hurry, guys. We can make it.
Oh, beautiful. All right.